The trouble with solving a system of linear equations is that there's two variables, and in the past we've only really been dealing with one variable equations. But if we can take those two equations and condense them into one, maybe we can get down to one variable. Let's see if we can do that now using substitution. So here we have these two different equations, but we're saying that we want to figure out where they have an x and a y that is the same. So we can move these x and y values kind of independently, but we're looking for that one special one. That one point where the x in the first equation is the same as the x in the second equation, and the y in the first equation is the same as the y in the second equation. Now to do that, we have a couple options, but we're going to use substitution in this case. So substitution requires we have something to substitute. So what we're going to do is we're going to either pick x or y and solve for it. And we'll see what that kind of does in a moment, but let's first pick an equation and a variable to solve for. One of the things I always look for is a one coefficient, because that's going to be real easy. If I can just get rid of everything else on the left side of this equation, I'm going to be left with y equals something. So we're going to use equation 2 here and solve for y. So now that I've solved for y, what that allows me to do is instead of writing y in this equation up here, the first equation, I can write 4x plus 12, which is going to get me down from two variables to one. So let's go ahead and do that. Let's take equation 1 and rewrite it. You'll notice that I left the spot for y blank. That's because I'm going to substitute in the thing that I know y is equal to at this potential intersection. So let's go ahead and put that in where y used to be. And now I have an equation with one variable x. So I'm going to go ahead and solve for x. All right, now I have half of my point. I have the x coordinate, so I know that these two equations are going to intersect, and they are at x equals -2, but now I need to find my y coordinate. Well, how might I do that? Well, since I know the x value, it should be pretty easy to find the y value. So you can use either equation 1 or 2. I always recommend using the original equation. Should point out if you made any silly mistakes in your algebra somewhere, but it shouldn't matter. When you plug in x equals -2, these should both be at the same y location because again, it's that point of intersection, 1x, 1y. So let's go ahead and plug in x, and we'll go ahead and solve for y. So now we know our y value. I'm going to go ahead and put that into my coordinate. And the reason that I'm writing it as a point is because that's what it is. We're looking for a pair, an input and output that works for both equation 1 and equation 2. Graphically, we would represent that as a point. All right, and now you know how to solve a system of linear equations using substitution. You can check your answer by graphing it using a graphing utility like Desmos and looking for that point of intersection. And in the next video, we're going to learn how to use elimination to also be able to solve these systems of equations.